You think of smell as instantaneous. A flower is brought to your nose and you smell it. But that's wrong. There is a delay. A tiny, almost imperceptible gap between the moment scent molecules enter your nostrils and the moment your brain says rose. This gap, this olfactory latency, isn't just noise in the system. It's information. It's the time it takes for a complex cascade of chemical reactions and neural signals to occur. Unlike light, which travels to your eye at a near infinite speed, scent travels at the speed of air. It has a physical presence, a journey, and every journey takes time. Your brain, without you knowing, is constantly calculating this travel time. Because smell has a travel time, your brain can use it to build a map, not of space, but of space-time. By comparing the arrival time of molecules in your left and right nostrils, a process known as olfactory stereo, you can determine the direction of a smell. But it's more than just left versus right. The gradient of a scent, how it strengthens or weakens over seconds, tells you something else. It tells you about movement. Is the source getting closer, or is it fading into the past? A sudden whiff of baking bread tells you you're near the bakery, but a faint, lingering trace tells you that you've just passed it. Your nose is performing a kind of temporal calculus, plotting the trajectory of events based on decaying molecular evidence. This temporal analysis allows for something remarkable: prediction. Your brain is a prediction machine, and the olfactory bulb is one of its oldest forecasting tools. When you smell the metallic, sharp scent of ozone in the air, you instinctively look to the sky. Your brain isn't just identifying ozone, it's retrieving a vast database of associations and predicting a high probability of a thunderstorm. The smell precedes the event. It is a warning, a scent from the immediate future. This is called predictive coding. The brain presents a hypothesis, storm is coming, and waits for other senses like sight and hearing to confirm or deny it. The future, in a very real sense, announces its arrival with a smell. If some smells predict the future, others are portals to the past. The olfactory bulb has a uniquely privileged connection in the brain, with direct links to the amygdala, which processes emotion, and the hippocampus, the architect of long-term memory. This is why a scent can trigger a memory so vivid and emotional it feels like time travel. It's called the Proust effect. When you smell old crayons, you aren't just remembering kindergarten. For a split second, the neural framework of that past experience is reactivated. You are feeling the emotional texture of a time that no longer exists. The original molecules are long gone, but the smell and the world it built is perfectly preserved in your neural architecture. So you can smell the near future and the distant past. But can you smell something that never was? The phenomenon of phantosmia, or olfactory hallucinations, suggests you can. People with phantosmia perceive distinct smells, like burnt toast or chemicals, with absolutely no corresponding molecules in the air. Their brain is generating a scent from scratch. This reveals something profound. Your experience of a smell isn't a direct reading of the world, it's a creation of the brain. If your brain can create a smell of the past, a memory, and a smell with no source, a hallucination, could it theoretically construct a smell for a future that hasn't happened yet? A truly predictive scent, untethered from environmental clues? The mechanism is there, the wiring exists. Perhaps the most direct way we smell time is by smelling its work. Time is not an abstraction, it is a physical process of entropy and decay. and decay has a smell. The scent of an old book is not the smell of oldness. It is the smell of specific volatile organic compounds released as the acids in the paper break down its cellulose and lignin over decades. You are smelling the slow, steady chemical reactions of time itself. The smell of fallen leaves in autumn is the smell of decomposition, the process of complex organic matter being returned to the earth. Each of these scents is a reading on a geological or historical clock. You are not just smelling an object, you are smelling its age. This idea scales down to human moments. When someone wearing perfume leaves a room, their scent doesn't just vanish, it lingers, creating a scent ghost. This ghost is a temporal artifact. The concentration of the scent molecules is a clock that started ticking the moment they left. A strong, rich scent means they were here just moments ago. A faint, ethereal trace means they were here perhaps an hour ago. Forensic scientists are even exploring how the specific degradation of volatile compounds at a crime scene can establish a more precise time of death. The air itself becomes a witness, holding a memory of events, a memory that fades second by second with the predictable laws of physics. Step outside. The air you're breathing is not a single entity. It's a complex library of temporal information. You are simultaneously smelling the diesel fumes from a truck that passed 10 seconds ago, the scent of cut grass from a lawn mowed 2 hours ago, and the deep, loamy smell of damp earth from a rain that fell yesterday. Each smell is on its own timeline of decay. Each tells its own story about the past. Your brain seamlessly processes this symphony of timelines, filtering and focusing, allowing you to navigate a world that is not just three-dimensional, but four-dimensional, with time itself leaving a constant, smellable trace on everything.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.